In this video, we are going to learn how to use a separatory funnel for two procedures known as extraction and washing. Extraction and washing are two techniques which are done in the same way but accomplish two different things. An extraction is where we have a solution of many things and we pull out a component that we want, and washing is where we pull out a component that we don't want. We do extractions or washing of reaction mixtures in a separatory funnel, and in this video I will be using some chemicals that are more colorful than what you'll be using in this experiment, just so they show up on the video better. It's very likely that what you're using in this experiment both will be completely colorless, but you will still be able to do the same thing. So in an extraction, we have an organic phase, which is ether in this case, and I've dissolved a yellow compound, the compound fluorinone, to make it yellow, and an aqueous phase, which in this case is made blue by dissolving copper sulfate. Since we know that compounds such as water and ether are not miscible, what we see in our separatory funnel now are two separate layers. But in order for one layer or for the layers to intermix, we need to shake the separatory funnel. And so place one finger over the stopper and invert it and shake it gently. While we're shaking it, every so often we want to stop and open up the stopcock because pressure will build up inside the sep funnel, and by opening the stopcock we release some of the pressure, and then we repeat this 2 or 3 more times. Once we've finished, we'll put this back into the ring stand where our layers should separate, and as you can see, we can see now a lower blue layer, which is our aqueous layer, and an upper yellow layer, which is our organic layer. Now, in this case, it was very simple to determine which layer is which because we knew that our aqueous layer was blue and that our organic layer was yellow. If we did not know that, we would be able to determine this based on the densities of the solvents. Since water has a higher density than ether, water will be the bottom layer. Now that we've got our two layers, we're ready to separate them. So we're going to drain off our lower layer into one Erlenmeyer flask. You'll notice that I've removed the stopper from the top of the separatory funnel. That's because if we forget to remove the stopper from the top, we won't get any flow out the bottom. And so now I've left behind just our organic layer. Now, if we want to make sure that there's no aqueous components left in there, we can do a wash by adding some water and repeating the same process of shaking the separatory funnel and venting. Because we're using ether, you may even be able to hear the separatory funnel venting because ether is a highly volatile organic solvent. Now again, that we're done, we'll let our layer separate, place it back into our ring, and again drain our lower aqueous layer into our separatory funnel. And by doing this multiple times, we make sure that any aqueous components have been washed out of our organic layer. Now that we're done, we can drain the rest of our organic layer, which has what we want, into our Erlenmeyer flask. But you'll notice we have not gotten rid of our aqueous layer yet. We're going to keep that until the end of the experiment, just in case we've made a mistake. That way we don't throw out a component that we want. Now, while all of the water should be in our first flask, it is possible that some traces of water are still with our organic layer. In order to get rid of any remaining water, we're going to add a drying agent, anhydrous sodium sulfate, which will just form a complex with water and form a hydrate of sodium sulfate. And so we will add couple of spatulafuls, and then start to swirl our flask. What we're looking for is whether or not the sodium sulfate clumps. If you may be able to see in the video that our sodium sulfate is not clumped up at all. If we had a significant amount of water in here, the sodium sulfate would have all clumped up and we would need to add more. But because it is still a fairly free-flowing solid as it is in the bottle, it tells us that we've gotten all of our water out of here and our solution is completely dry and we're ready to filter it and evaporate our solvent.